Welcome to this rigorous scientific lecture on using artificial intelligence for metacognition. Today we're going to explore how you can systematically stop fooling yourself about your actual progress in learning. Let me start with a fundamental question. Why do we consistently overestimate our understanding? The answer lies in what cognitive scientists call the illusion of explanatory depth. When you read something and think, I understand this, your brain is confusing familiarity with comprehension. You've seen the words before, they feel comfortable, but can you actually apply the knowledge? Research from cognitive psychology shows that humans overestimate their comprehension by 200 to 300% on average. This isn't a character flaw, it's how our brains are wired. Here's a visualization. The red box represents your perceived knowledge. The smaller teal box is your actual knowledge. That gap between them? That's where self-deception lives. So what exactly is metacognition? It's thinking about thinking. More precisely, it's your ability to monitor and regulate your own cognitive processes. Metacognition has two critical components: monitoring, which is assessing what you know, and control, which is regulating your learning strategies based on that assessment. Most learners are terrible at the monitoring part. They can't accurately gauge what they know versus what they don't know. This is where AI becomes incredibly powerful. Now let me explain why artificial intelligence is uniquely suited for metacognitive training. AI has three properties that make it ideal for this purpose. First, AI provides instant, unbiased feedback loops. Unlike a human tutor who might be polite or subjective, I will tell you exactly how wrong you are, immediately. Second, I can generate unlimited practice problems calibrated to precise difficulty levels. This means you can test yourself repeatedly at the exact edge of your competence. Third, I can track microscopic patterns in your performance over time. It notices things you can't see about your own learning trajectory. Now let me introduce the core exercise. This is a three-step protocol. Predict your performance, test your actual performance, and track the gap until it shrinks to near zero. Step 1 is the prediction phase. Before you attempt any problem or task, you must make a quantitative prediction about your performance. Ask yourself, on a scale of 0 to 100, how confident am I that I can solve this problem? Write down a specific number, not a vague feeling. Also estimate, how long will this take me? Be specific. Not a few minutes, but 7 minutes. Precision matters because it forces real cognition. Here's what a proper prediction looks like. You write down your confidence level, your time estimate, and your expected score. This creates accountability. Step 2 is the testing phase. Now you actually attempt the problem. And this is where AI becomes crucial. Use AI to generate problems that are slightly above your current level. Not too easy, not impossibly hard. The zone of proximal development is where metacognition improves fastest. Set a timer. Measure actual time taken, not approximate time. If you estimated 8 minutes and it took 23 minutes, that's critical data about your self-awareness. Have I evaluate your answer with detailed rubrics, not just correct or incorrect. You need granular feedback on where specifically your understanding breaks down. Step 3 is gap analysis. This is where the real learning happens. You compare your prediction against reality and quantify the discrepancy. The metacognitive gap equals the absolute value of predicted performance minus actual performance. This is your self-deception score. Large gaps mean poor self-awareness. Small gaps mean accurate metacognition. Your goal is to drive this gap towards zero over weeks and months. Let me walk through a concrete example. Suppose you're learning calculus and you want to master the chain rule for derivatives. Day 1, initial prediction. You watch a video on the chain rule. You feel like you understand it. You rate your confidence at 80%. You predict you can solve 8 out of 10 problems correctly. This feels reasonable based on how well you understood the video. Now you ask an AI to generate 10 chain rule problems at intermediate difficulty. You attempt them with a timer running. Actual results. You only solved 3 out of 10 correctly. It took 47 minutes when you estimated 20. Your metacognitive gap is 50 percentage points. This is painful but incredibly valuable data. The gap tells you that your perception of understanding was completely disconnected from reality. You were fooling yours. But now you know, and knowing is the first step. Days 2 through 7, involve deliberate practice with continuous tracking. Each day, you repeat the predict, test, track cycle. Ask AI to generate 5 new problems daily at your current competence edge. As you improve, the AI increases difficulty slightly. Log every prediction and result in a spreadsheet. Prediction, actual score, time estimate, actual time, and calculated gap. Do this religiously. Here's what your tracking table looks like over 5 days. Notice how the gap shrinks from 50 points to 0. This is metacognitive calibration happening in real time. By day 5, your predictions match reality. This is the goal. Not just being good at calculus, but being good at knowing what you know about calculus. Let me do a back-of-the-envelope calculation to show you the time savings from good metacognition. Assume you study 20 hours per week with poor metacognition. Research suggests about 60% of that time is spent reviewing things you already know or studying things too advanced. 20 hours times 0.6 equals 12 wasted hours per week. That's 12 hours of illusory productivity. 12 hours per week times 52 weeks equals 624 hours per year. That's over 78 full 8-hour days wasted annually. With calibrated metacognition, you could cut wasted time by 70%. That recovers over 400 hours per year that you can redirect to actual skill acquisition. 437 recovered hours equals 54 additional 8-hour days of productive learning. This is the compound interest of good metacognition. Now let me introduce an advanced technique called difficulty calibration. This helps you find the optimal challenge level. Most people study material that's either too easy or too hard. Too easy, and you waste time on diminishing returns. Too hard, and you spend hours frustrated without learning. The sweet spot is material where you predict 60 to 70% success rate. This is the zone where your brain has to stretch, but not break. Here's a visual guide. Green is too easy, red is too hard, orange is the sweet spot. Use AI to continuously adjust problem difficulty to keep you in the orange zone. Tell the AI, generate problems where I should score 65% based on my last 5 attempts. The AI can analyze your performance history and calibrate perfectly. Now you might be asking, how long until my metacognition actually improves? This is a great question, and the answer is empirically testable. Research from educational psychology shows metacognitive accuracy improves significantly after 20 to 30 prediction cycles. This typically takes 2 to 4 weeks of daily practice. The improvement follows a logarithmic curve, not linear. You get huge gains in the first week, then incremental improvements after that. This graph shows the typical trajectory. Your gap starts at 40 to 50 percentage points, drops rapidly in the first week, then gradually approaches 0 over the next 3 weeks. Let me give you an analogy. Metacognition is like a thermostat for your learning. Most people are learning without a thermostat. Imagine trying to maintain room temperature without a thermometer. You guess it feels warm, or it feels cold, but you have no quantitative feedback. You waste energy heating an already hot room. Poor metacognition is exactly this. You're learning without measurement instruments. You think you understand, but you have no data to verify that intuition. AI gives you a precise thermometer plus automatic temperature adjustment. It tells you exactly where you are and adjusts the difficulty to maintain optimal learning temperature. Now let me warn you about common pitfalls. These are mistakes that will sabotage your metacognitive training. Pitfall 1. Making vague predictions like, I probably understand this. Vague predictions can't be tested. You must use numbers. 65% confident, not pretty confident. Pitfall 2. Cherry-picking easy problems to boost your ego. This defeats the entire purpose. You must let the AI select problems at the edge of your ability. Pitfall 3. Not actually tracking the data systematically. If you don't write down predictions and results, you'll rationalize failures and fool yourself again. Use a spreadsheet. Pitfall 4. Giving up after the first painful reality check. When you discover you only scored 30% when you predicted 80, that's painful. But that pain is signal, not noise. Let me introduce an advanced application called transfer testing. This checks if you've actually learned principles or just memorized patterns. After practicing chain rule in calculus, test yourself on a physics problem requiring the chain rule. If you can't transfer the knowledge, you didn't really understand it. Ask AI to generate analogous problems in different contexts. Same underlying principle, different surface features. This reveals whether you learned deep structure or surface patterns. Predict your transfer performance, then test it. The gap here is especially revealing. Most people overestimate transfer by 300 to 400%. Now let's talk about why this works at a neurological level. This isn't just psychology, it's neuroscience. Your prefrontal cortex monitors performance and adjusts strategies. But it needs accurate input signals. Without data, it operates on feelings, which are notoriously unreliable. The prediction error signal is one of the strongest learning signals in the brain. When you predict 80% and get 30%, your brain releases dopamine and norepinephrine that strengthen metacognitive circuits. Repeated prediction errors literally rewire your self-monitoring networks. After 30 cycles, your brain becomes significantly better at estimating its own knowledge state. This is measurable with fMRI. Let me give you a quantitative way to measure your overall metacognitive progress. I call this the metacognitive score. Metacognitive score equals 100 minus your average absolute gap over the last 10 predictions. This gives you a single number between 0 and 100. A score of 95 or above means expert-level self-awareness. Your predictions are consistently within 5 percentage points of reality. A score of 70 to 85 is intermediate. Below 70 is beginner level. Track this score weekly and watch it rise. Let me share a real-world example. A medical school student used this exact protocol to improve her anatomy knowledge. Week 1. She predicted 75% on an anatomy quiz, scored 48%. Gap of 27 points. She was shocked but continued the protocol. Week 4. She predicted 82%, scored 79%. Gap of 3 points. Her metacognition had calibrated remarkably. Week 8. She predicted 91%, scored 93%. Gap of 2 points. She now had near-perfect self-awareness of her anatomy knowledge. Outcome. She passed her board exams on first attempt, and estimates she saved over 200 hours of inefficient studying by knowing exactly what she needed to work on. Now let me talk about the compounding effect over years. Good metacognition isn't just a one-time boost, it compounds exponentially. Year 1. You save 400 hours and learn 30% more efficiently. You can acquire 1.3 times the skills in the same time. Year 5. That efficiency gain has compounded to 3.7 times baseline. You're learning almost 4 times faster than someone with poor metacognition. 1.3 to the 5th power equals 3.71. This is the mathematics of compounding returns on metacognitive investment. Over a career of 40 years, this gap becomes enormous. Someone with calibrated metacognition will acquire perhaps 10 times the expertise of someone who chronically fools themselves. Let me give you a practical 30-day protocol to implement immediately. This is the exact sequence that produces results. Days 1 through 7. Choose one skill you're trying to learn. Make 5 predictions daily about problem-solving performance. Track all results in a spreadsheet. Days 8 through 14. Analyze your gap pattern. Where do you consistently overestimate? Verbal reasoning, calculations, memorization? Identify your blind spots. Days 15 through 21. Adjust your predictions consciously. Try to predict conservatively in areas where you've been overconfident. Watch your gap shrink. Days 22 through 30. Test transfer. Apply the skill in new contexts. Predict your performance in the new context and measure the gap. This reveals true mastery. You might ask, what if my gap doesn't shrink after 30 days? This is a legitimate concern, and there are specific reasons this happens. Reason 1. You're not making precise enough predictions. Saying around 70% doesn't work. Say 68% and commit to it. Reason 2. You're not actually testing yourself. You're reviewing material. Testing means attempting problems under time pressure without notes. Reviewing doesn't provide metacognitive feedback. Reason 3. Problems are too easy or too inconsistent in difficulty. Use AI to maintain consistent difficulty at your 65% success rate threshold. An important integration is combining this with spaced repetition systems. These two approaches are synergistic. Before each spaced repetition review, predict your recall accuracy. Will you remember this card? How confident are you? Make a prediction before revealing the answer. Track prediction versus actual recall. This reveals which material you think you know, but don't. Those false positives are your biggest learning opportunity. A. I can adjust your spaced repetition intervals based on metacognitive accuracy. If you consistently underestimate recall, intervals lengthen. If you overestimate, intervals shorten. Let me cite the scientific evidence supporting this approach. This isn't speculation, it's based on decades of research. The Dunning-Kruger effect shows that incompetent people drastically overestimate their ability. The gap between perceived and actual competence is largest at low skill levels. Judgment of learning research shows immediate judgments are 40% less accurate than delayed judgments. You must wait at least 24 hours to accurately assess what you learned. Retrieval practice studies demonstrate that testing improves metacognition more than restudying. Each test is a calibration event for your self-monitoring system. Calibration training research shows that systematic practice with feedback improves metacognitive accuracy by 35 to 50% within 4 weeks. Let me teach you one final advanced technique, using confidence intervals instead of point estimates. Instead of predicting 75%, predict between 70 and 80% with 90% confidence. This forces you to quantify your uncertainty. Track how often your confidence intervals contain the true result. If you say 90% confidence, but the true result falls outside your interval more than 10% of the time, your intervals are too narrow. Well-calibrated thinkers have confidence intervals that accurately match their stated confidence level. This is the gold standard of metacognitive precision. Let me conclude with this critical insight. Metacognition is the meta skill that multiplies all other skills. Every hour invested in calibrating your metacognition pays dividends in every other domain of learning. It's the skill that improves how you acquire all other skills. AI makes this training scalable, precise, and immediate in ways that were impossible before. You have access to a tireless tutor that generates infinite practice problems and perfect feedback. The protocol is simple. Predict your performance, test your actual performance, track the gap. Repeat this cycle until your gap approaches 0. This is the systematic path to stop fooling yours. Start tomorrow. Pick one skill. Make 5 predictions. Measure the results. You will be shocked by the initial gap between what you think you know and what you actually know. And that shock is the beginning of true learning. Remember, the goal isn't just to be competent at a skill. The goal is to accurately know your own level of competence at that skill. That is metacognition, and it is the foundation of all genuine expertise.